Good morning, everybody. I hope you can hear me. So if the voice is not too good, please give me a short message via the chat window. So let us start for today the webinar on Cobra WireRolling. First of all, DataM is mostly known as provider of software solutions for the roll forming industry. And of course, as you can imagine, roll forming and wire rolling are technically wise very similar processes, and therefore it makes sense to use that technology also for wire rolling. Before we begin, a short brief introduction on the contents. What is DataM Sheet Metal Solutions doing? What is the history of wire rolling at our company? What are the wire rolling projects, applications for Cobra? Short introduction of the software packages. We will have a look on the design purposes or design possibilities with Cobra RF wire rolling. And of course, the most important part then in the next step is the finite element simulation. We will be having a short conclusion and an outlook on future aspects, and in the end, the possibility to ask questions. DataM itself is a worldwide operating company with, at the moment, about 40 employees. The main activities are, of course, software development and development of products and services for the roll forming industry mainly. Here, design and simulation software as the major aspect, databases for applications, for example, for role management, project management, and of course, devices to do quality checking of roles and of profiles with role scanner and the profile scanner. Of course, there is a development for flexible roll forming, which already has been shown in the past a few times, and as a field that is not the youngest solution, but a solution that has been undergoing quite a lot of development in the past 3-4 years is wire rolling. DataM has its headquarters close to Munich. The big M's here in the list are showing subsidiaries of DataM. This is mainly Poland, Sweden, and the UK. In Europe, we have India, Brazil, and the US. The smaller M's are representations of DataM that are being driven by partner. The history of wire rolling, there were first solutions for an automatic design of the forming steps in '96 based on the CAD system ME10 that was coming from Hewlett-Packard, which had at that time quite good possibilities to develop a solution like that. After Hewlett-Packard has sold ME10, the development of the CAD system also was slowing down drastically, and therefore we also switched to AutoCAD here. Today, wire rolling is a fully integrated module in the Cobra RF bundle. It is also offering a simulation of the wire rolling process. So we started first of all with a three-dimensional approach, but due to some limitations in the wire rolling process, very high compression rates, extremely high forces, meshing and so on, we found out that the stability of the process would be makeable, but as an industrial application, it was a little bit too complex, especially as the calculation times are quite high. So we decided to start with a 2D approach. First research have been made in 2011, and in 2012, the complete solution for wire rolling for the design and simulation part was made in 2012-2013. Now with TÜV version Cobra RF 2013, this solution is also available. So the normal process when you get an inquiry from a customer is that you create a new project, you get a customer drawing, you get the specifications and so on. You do the definition of the cross-section and the assignment of material properties, the definition of the initial cross-section, the definition of forming steps, the purchase of the material, manufacturing of the rolls for the trial of the machine, investigation of the results, and then redesign the roll design to fix some problems or typical problems in wire profiles would be a bad filling grade or whatever. And in these situations, Copra could help you in various areas, for example, during the definition of the project, during the definition of the forming steps, and of course, with the help of a simulation. The simulation can give you a quite quick idea what the quality, the expected quality of a wire profile could be. So the software packages are split into two parts, like the roll forming part. We have the design portion of wire rolling and we have the simulation portion. So the design portion is based on the CAD system AutoCAD, where you can do the definition of the profile, the definition of the intermediate steps, the forming steps, which is quite important, and where you can do an automated roll design and, of course, underlaid project management. If you have done the design, you can do an instant transfer of the model into the finite element simulation, working more or less in the same way as it is for the roll forming part again. The forming steps, the individual forming steps can be simulated, cross-checked. You can do an investigation of the simulation results. So very straightforward, as you do not have to do very much in this area because all the model preparation and so on is more or less being done automatically. So the wire rolling solution is split into three parts. You have on the left-hand side usually the project management done by the CAD Finder program. You have the model area where you do your design, more or less with the AutoCAD features. You have here a spreadsheet table where you can see all the individual forming steps for the wire, and we will see that a little bit closer in a short presentation, live presentation. In the first steps, the final cross-section needs to be defined. It can be imported from a CAD system or it can be drawn in AutoCAD as a polylinear or spline. The definition of the initial cross-section, well, the initial cross-section is usually around wire, and the definition or the first layout of the forming steps is being done then more or less automatic with a lofting method, which is kind of a morphing technology. You can do an automatic definition of flat wires, a manual design of cross sections and combinations of the different possibilities. Now in this situation, I showed video of a simulation of a 2D simulation of a wire. So where you can see how the wire is being deformed, the round wire is being deformed, first of all to a flat wire, and then step by step to a shaped wire. Very good can be seen the filling grade, the movement that the wire would like to undergo. And the defects that can be expected. In the profile design, it is very easy to copy, duplicate, or delete individual cross-sections to replace profiles, to make automatic optimizations of the position, scaling of the profiles, changing the type of compression or the absolute compression, and do an lofting in between individual cross sections also afterwards, after the first initial strategy has been layouted. In the table of the spreadsheets table, you can see all the forming steps with the profile number, the relative and absolute compression, the cross-section area in square millimeter, the relative change of the cross-section area in each step, and the horizontal distances between profiles. It's very useful for the navigation within the design, as the selected profile that you hit in your list here is displayed in the model area. It also contains functions for the design of profiles and roles. Again, you will see that in a live presentation. So in the role design, the definition of the machine data is the first steps. You can define bottom and top axis, side roles, or any accessory axes that are free-definable in position and rotation. The role design can be done quite automatic, other than in role forming. The outside shape of a wire is always the base for the design, and then the top and bottom roles can be made more or less automatically. If side roles need to be made, these are usually done with normal CAD functionality. Same is valid for accessory tooling. Of course, as soon as you have all the information inside Copra, you have all the following down on the way lists and the bill of materials that you need. So, for example, a bill of materials for the roles, the NC contours of the roles for manufacturing. You can create dimension roles, the assembly plans, and you can transfer everything to a database management system. Now we are going to the live presentation of part number 1.
Hello everybody, my name is Johann Haase and I'm a member of the development team for our wire rolling software. Now I want to give you a short presentation of our design software, Copra RF wire rolling. The first thing I have to do is to create a new wire rolling project and to give it a name and give the name star. OK. And then I can open any profile of a AutoCAD drawing. And select the polyline as profile. Now I have the final shape of our wire. The next step I have to do is to define the initial wire. I select a round shape. We come to this dialog. I can define the relative compression between the first profile and the final section. I select 40%, and as you can then see, this will give me a diameter of 8.08 millimeter. If I don't like this, if I want to have a diameter of 8.0, I can also select this and see the relative compression of 38.86%. If I click on OK, I can see the initial wire, the round shape. This was the polyline of our AutoCAD drawing. I can delete that, and I can see the second profile, the final shape of the wire. The next step I have to do is to define the symmetry axis. This is preparation for then defining the forming steps. So I define it from the middle of the profile. So now the symmetry axis is defined in both profiles. The next step is to define the shaping steps. This is done by a lofting method. I can select the number of intermediate steps. In this case, I want to select 2. I can select the type of compression, loft-driven, equivalent relative distribution, or equal absolute distribution. I select equal relative distribution. I can also set an horizontal distance between the different forming steps. I want to have it the same distance as it is for the first profile. If I set all the parameters, I can click on OK, and the profile steps are created automatically. You can see the yellow line is always the profile, so the round wire, the second profile, third profile, the fourth profile, the final wire. If I want to see that in 3D, I can select the free orbit here. And now I can see the forming steps in a 3D view. This gives me a good idea how the forming is done. So now I can go back to the 2D view and delete the helping contour for the automatic creation of the forming steps. As you see, I can always the line in the spreadsheet I selected is also shown on the design area. I can also select 2 lines or all the lines, and then I see also the different forming steps at once. The next step is to create the axis. I can use the automatic function. Therefore, you have to create some machine. I created already one. You can look at it under modify. So you see the shaft length, the diameters of the bottom and the top roll, the gear ratio, and the vertical centers of the rolls. I have selected this machine, click OK and Axis, and now you can see these red lines are the axis for the rolls. This was automatically done for all stations. The next step after I created the axis is to create the rows. I can also use an automatic function for this. I select create rows, set the width, I want to have it 30 millimeters, the outer radius 0.5, also the inner radius 0.5, and the gap between the rows I set to 0.2. I want to create the top axis and also the bottom, the row also for top axis and also for bottom axis. Select OK. You can see the top and bottom row are created. I can also do this for more than one station. I again select 2 lines in my spreadsheet. Select create rows. You can see the settings are as I said, as I selected it before. I only have to click on OK, and the rows are created for the last 2 forming steps. So now I have the initial wire diameter, the wire shape, round shape, second forming step, third, fourth, and these 3 forming steps has also the roles. After I have done this, I want to check this design by simulation. This is the functionality for the simulations are under the wire ribbon. I start the FEA RF Project Manager, which manages all the simulations for one design project. I have to create a new simulation project here on the webinar, new folder, star, again a new folder, sim 01. I select this folder, give a project name. I can also set sim 01 designer and any comment I want to add, I can do it. Okay, as I said this, I'm done in the FEI Project Manager, and I can load this project into Cobra. Then I can turn on the Cobra to FEA dialog, and I see the different masks for setting up the model. The first dialog is the meshing. I can here set the subdivisions transversal, and in a specific range. I select here 0.7. That makes the simulation a little bit more faster, and this is helpful during this webinar to have the chance to see the simulation really online in real time. The second mask is the material. I can define the Young's modulus, the Poisson ratio, and also the plasticity parameters, the flow stress curve, or if I have some data from my material supplier, I can also do this from material specification. The yield strength, the ultimate tensile strength, and the 80% elongation. The last dialog is setting some process parameters. I can set the friction between rolls and wire. I select 0.05 here, and I can select if I want to retain the wire during the unloading or if it should be free during the unloading. I select retain wire during unloading because this makes the simulation more stable. Then I click on Run Project, and Cobra FER RF WireRolling is automatically started, as you see here, and the model is prepared. Normally I have to do nothing more, only click on Start, and the simulation is running. So the monitor job window opens, and you can see here the current increment where the simulation is calculating at the moment. Some more parameters. This analysis time. One station takes 1 second in the simulation. So I can see here the analysis time is now 2.4 seconds, and this means that the simulation is calculating in station 3 at the moment. I can see the wall time, how long the simulation takes in reality, and some more data. I can close this by click on OK. We can have a short look at the simulation model. You can see the round wire with the finite elements, and also the top rows. They are laying above each other, and you can see the different shapes of the rows. The same for the bottom rows. I can go back to the monitor window, look where the simulation is at the moment, and I see, okay, it's at the moment calculating station 4. Now the rows are closed in station 4 and only opening the rows, and I can see now the status of the simulation is complete. I get an exit message 3004, that means the simulation was successful, and I can open the result file. I can open the result file also during the simulation and have a look while the simulation is running. Now I can, for example, go through the stations. I see station 2, first forming step, station 3 and station 4. Now I have to change to have a closer look at the forming. Maybe I want to see the forming like a video. I can monitor all the simulation results. You can see the rows are closing. Now for station 2, closed. The rows for station 2 opens. The rows of station 3 are closing. Okay, station 3 is closed and opening now. I can also stop this, zoom a little bit in, and let it run again. So this is the last station. Again, the rows are closing. You can see the deformation. The rows are opening. And we have the final shape. If I want to do further investigation, I can, for example, look at any time what the cross-section of the wire is, the absolute compression. This takes a while by first time clicking on it, because all the results have to be taken into account. So you can see the absolute compression at the end, or in station 3, for example, you can see the relative compression. I can also do a plot of the cross-section area. So we started with 50.2 and ended in 30.3. I can also do this for the absolute compression or the relative compression. I switch back to the model, go to the last station, and can compare the designed shape with the shape I got from the simulation. Let's see. Okay, the automatic shapings, automatic designed shaping steps are was not perfect. I can see here a little material going into the rolling gap, and in the top there is some material missing. If this shapes meets the tolerances that comes from the customer, I can say okay, I can live with that. If I have to do some optimization, I can switch back then to the design software and change the forming steps. I can also have a look on the strains, for example, the total equivalent plastic strain. So you can see where the highest values of strain are placed in the profile. This can give me some hints how much rest formability has my final profile. I can also look at, for example, at the hormesis stresses, the absolute displacement, so I can see which part of the material don't move, which moves the most. Besides the geometrical and the strain and stresses, I can also look at some process information. I can see, for example, the contact status. Maybe I want to see where the roll, in which place the rolls touches the wire first. This is station 4. So you can see the first part of the rolls that hits the wire is in this area, and how the contact between roll and wire develops. Okay, I have some more information about the contact between roll and wire. Here, for example, the normal stress at the scalar. So I have to look at the legend to see the values. Also the friction stress between rolls and wire. You can also do this with a vector plot. So I set the scaling factor for the vectors to have a good view of this result. So I can see the most of the contact normal stresses are in these parts, the let's say the side arms of the star. If I want, I can do this also for the friction stresses, and some other interesting things may be the forces on the rolls during the forming. I can also have a look at that. This again takes a little bit calculation time. So I can see how the how high the forces for the different stations are. The highest forces in this example came up in station 4, and approximately 58,000 Newton. I can also add this to a report. I have a short presentation afterwards. And another interesting thing may be the distribution of forming work over the different stations. So I can see station 01 was the initial wire, so no forming happened there, therefore also 0%. Station 2, 22%, station 3, 33, and station 4, 44%. So maybe I have to do a little bit work on this to get a smoother distribution of the forming work. I can also add this to a report, and if I want to, I can also do a plot of the forming work over the different stations. Okay, as I told you, you can do reports. You can add at any time a screenshot of the model and add then some commentar. So I click on Add New, any comment, and maybe you want to do the same for station 2. new comment 2. You can then create HTML reports or Word documents. So I want to do it in station order. I click on Make Station, showing report, and now you can see in my internet browser, as it is an HTML report, the screenshots with the comment. Comment 2 was in station 2, so we have station order. I first made a picture in station 4 and secondly in station 2, but due to the station order of the report, they are in a different order. And I can see also here any comment. This was my first comment. Okay, let's go back to the simulation. As I can do reports, I can also do create an animation of the forming steps. I think you saw one animation of a simulation during the presentation of the software. And yeah, I can define the start station for the animation, the end station, and then create a video. Okay, so after I have done the investigation of the results, I can either go back to the design software and do some modification on the rows, or can create the drawing of the rows